In the first experiment, we are going to create a golden rain. To start, an aqueous solution of potassium iodide was prepared. It was a colorless solution. And then some lead-2 nitrate solution was added. As observed in the video, a yellow precipitate was formed. This is lead-2 iodide. The reaction is precipitation, involving two aqueous solutions that reacts to form a solid precipitate. A yellow precipitate of lead-2 iodide was forming, and some additional distilled water was added. And the liquid is mixed. Then the mixture was heated to cause the precipitate to dissolve. The precipitate dissolved because at higher temperature, solubility increases, allowing the precipitate formed earlier to dissolve to form a colorless solution. However, upon cooling, crystallization starts to occur, where crystals of lead-2 iodide was forming. And this is the golden rain phenomenon. The compound that formed these crystals is the same, lead-2 iodide, but in different form from what we observed earlier. The chemical reaction involved is precipitation, and the physical process that form these crystals is called crystallization, where golden flakes of lead-2 iodide was forming. It looked like glitter to you, however, this cannot be used because lead is a toxic metal and shouldn't be used by consumers like us. Unfortunately, you can't try this in the lab because lead-2 ion is a toxic metal and students are not allowed to experiment with it at the secondary and junior college level. The next experiment involved the reaction of cobalt chloride solution, which is a pink solution. Upon adding an acid like hydrochloric acid, there will be a change in the color observed. Look carefully. The pink solution gradually turned blue with the addition of acid. This is due to a chemical equilibrium shift. However, if we add more water to the blue solution, there will be a change in the color as well. So it will reverse back to the original pink color. In fact, cobalt chloride solution or cobalt chloride paper is used as an indicator to test for the presence of water. So the color can change from blue to pink and back to blue using water and acid. This is what we call chemical equilibrium. We can try this at home, where we can electrolyze water to form hydrogen gas and oxygen gas. You just need a battery to start breaking down water. You may need to add some acid or bicarbonate solution to increase the electrical conductivity. So as you can observe in the video, there are effervescence in the two test tubes. One is oxygen gas and one is hydrogen gas. The volume of one of the gas is larger than the other. So one of the gas will be collected in larger volume. As you can see, there are effervescence in both electrodes. This proves the presence of gases. You can try this at home because it's very safe to carry out the experiment. The gas with a higher volume is hydrogen gas. The one with the lower volume is oxygen gas. Both gases are not soluble in water, so they can be collected using this method. Now, the next experiment is an experiment that you shouldn't try because it's very dangerous. Is the decomposition of sugar in gummy bear. You need to have this chemical potassium chlorate in order to carry out the experiment. So first, you heat until it melts or form the molten state. So it takes a while for potassium chlorate to melt. And make sure it's clean so that there will be no organic substances present. Then a gummy bear is added. Whoa. This is an example of a redox reaction or decomposition, where the potassium chlorate will oxidize the sucrose in gummy bear to produce new products, and a lot of energy is given out in the form of heat and light. The color looks purple or violet because of the presence of potassium, and potassium chlorate is reduced to potassium chloride. Another experiment involving the release of heat or heat absorption is this. So, in this experiment, barium hydroxide was reacted with ammonium nitrate. This is an endothermic reaction where heat is absorbed. So, water was actually added to below the beaker. The reason is to show the effect of endothermic reaction where heat is absorbed from the surrounding, causing the water to become ice. As the water freezes, the beaker that was placed above it will be stuck on it. Unfortunately, the temperature reading cannot be shown. The temperature will actually drop or decrease because the reaction absorbs heat from the surrounding, causing a decrease in the surrounding temperature. So this experiment cannot be carried out at home because the chemicals are not available in any household material. So the chemical will actually mix to initiate the reaction. It actually happened quite rapidly lah. But because a lot of chemicals are added, and you can see that he can lift up the beaker easily. Why? Because the water beneath the beaker has freeze and stuck to the beaker so that the whole structure can be lifted up. And when he reads the temperature reading decreases. It's a reaction that absorbs heat from the surrounding. So some real-life application of this include ice pack or cold pack that is used to decrease a person's temperature when someone experiences fever.